I'm Jeremy Kitchen. I'm a systems engineer and HBuilder. We're based in downtown Los Angeles. We use Puppet almost exclusively for managing our servers. We have other tools for deploying code and such, but the servers itself are full stack managed by Puppet. I've been writing modules for a while, some good, some bad, some that I'm not particularly proud of, but those are mostly a long time ago, and I've learned a lot of lessons about how to write better modules and some gotchas and some stumbling blocks that I ran into, and I'm hopefully I'll be able to convey those and show you how to work around them or not run into them in the beginning, and also to just feel more confident writing modules, because it's really not that hard if your module falls into this pattern that I'm about to talk about. So first, let's start about what a module is. So a module is a distributable unit of Puppet code. So that code can be actually Puppet manifests. It can be factor plugins. It can be custom types and providers. It can be all sorts of things. But it's the kind of like the tarball of Puppet code. So it's published on the Forge. It's what a lot of people are publishing on GitHub. If you're like me and you have yet to publish on the Forge because you're afraid that people are going to look at your code. And it's kind of a container of functionality for a system. It's kind of like the very base building block. Not quite base, because obviously Puppet built-in types and stuff are very basic, but you build on top of those. And most modules that I've run into or have had to build fall into kind of a pattern. That pattern is that there's a package, there's a config file, and there's a service to run. Like 90% of modules that I've written are this basic thing. There's some things that go little side components. Maybe your service needs a check that the config is broken before you restart the service, but for the most part, you always modularize most things that you're going to use on the system. The pros to using a module to do this instead of trying to manually do it or on the system itself, without even Puppet involved, is that it provides a level of abstraction. So you can just say give me SSH or give me Redis or give me whatever, and if the module developer, or if your module is written properly, it'll work. It'll have same defaults, and it will work on almost any system you have that you feel like porting it to. And that's the other thing, is that a good module, or the better a module is, the more operating systems it's going to support, and the more confidence you can have in being I just need Redis, so you include Redis, and it works on Red Hat, it works on CentOS, it works on Ubuntu, it works on FreeBSD, whatever. And that's really powerful, because now you don't have to think about how do I need to install this, where's the config file, what are the options, just include Redis, that's all you have to do. So part of, so the very, very basic module is, and this is going to be a very code-dense talk. I'm sorry for the people in the back, I didn't think about the lowness of the screen. I'll have the slides online afterward, and really the concepts are more important than the code, so don't feel like you have to memorize every bit of code. I feel more able to convey thoughts in code, so hopefully I can do that to you with you guys too. But you have a manifest directory, which actually has the manifest that the module is made of. And you have 5 different manifests that each have a particular responsibility in the module, and then your template if you have a config file. And those work together to actually create to manage the system, the software. So we're going to dive in a little bit into what they are. The default PB file is kind of like the place where you put anything that is different, maybe based on facts. So either operating system, or you have a custom fact in your module that maybe your hardware has a particular piece of functionality that changes behavior that the user shouldn't have to think about too much, this is kind of where you put that. If you're looking at existing modules, you're going to see a lot of params classes, and that's pretty much what this is. The params name, I think, stems from prior to when Puppet had like proper parameterized classes, but that's also well before me, so I'm not entirely certain the history. I think there's a bit of a movement to try to like switch to using defaults because it's more indicative of what it is, instead of like some people will think that that's how you do the parameterized class, like you set these variables outside your manifest or outside of the module and then include them or something like that, which is not how you do parameterized classes. So you got in here like, you know, the package name, the service name, config path, log file, storage path for 2 different operating systems, and the general way you deal with like haven't ported it to that platform yet is just make it fail. Because it might work out of the box, and if it does, great. Someone like just throw another thing in there that says like also on Solaris do this, or this is the name of all these things. But this also provides a nice place to do the portability. If you do the rest of the module properly, this is about the only thing you have to change to support in your operating system. Because you just kind of tell where the file is, what the service name is, the package name. If it has to be a custom provider or something like that, like on OS X, maybe you're using Homebrew or Mac ports or something, so you have that. That's kind of where this stuff goes. And then that goes into the main class of the module. So this is your basically your interface, and there's a lot of stuff up here, but I'm going to cover each part individually. This goes into the main class. This is your kind of primary end user interface to your module, and it has things like the parameters and setting all this stuff up, and there's a bunch of scary stuff at the bottom. It's not that scary. It's just we'll cover that. This is also the parameters are kind of like your API. So for the most part, what I do is I go through the config file and I templatize it, and then I make each one of those things a parameter on the class. There are other ways to do it. Some people use like an option hash or something like that. But this is kind of your API. So kind of think about like what you need to have at the top level and what either can be just ignored or needs to just be like, trust me, this is the right default or something like that. But this is kind of what your end user has. So we'll focus on the parameters here first. My rule with modules is that, or pretty much with any parameterized class, is that every parameter should have a default, and that should be same, whether that's same for your environment or not. If you're writing the module, it probably should be same for your environment. I generally try to stick with what is in the config file that ships with it as a package. But having the same defaults means that someone can easily just turn it on to say include foo, and they have foo up and running. Also, naming foo. I should have actually done this with the SSH, because all the stuff that I'm going to show I could have applied very easily to SSH, and then I would have had an SSH module. But yeah, we get foo instead, which is the completely made up edit. I thought about actually writing the foo package, but lazy. Had other stuff to do. So then you also have down at the bottom there, it inherits foo defaults, and what that does is that brings all the variables that are in scope in the foo defaults into the scope of this particular class. You can reference them, you can use them. You can't modify them. You might be able to modify them, I'm not entirely certain, but you can't. You won't be able to, you might not be able to modify them. But it allows you to use them, and they're just like top scope. You don't have to try to like foo defaults variable name, it's just right there. And what that also does is later I'll show you that those will end up being accessible in your templates very easily. So the next part is, we're sanitizing, or not sanitizing, but we're validating our parameters. So through here, we're just checking to see using the IP address function, which is from the Public Lab standard module, to check to see if the listening argument is an IP address. Because if it's not, your application probably isn't going to start. and now you don't have to debug it. So if you can figure that out before Puppet runs, that makes it a lot better, especially if you change something and that breaks it, and maybe restarting won't work. You'll catch it before it tries to restart and then takes your application down. The verbose bool thing, that's since you can't reuse a variable name, or you can't modify a variable once it's been declared, there's a lot of, you'll see like with my code specifically, you'll see bool, but sometimes you'll see like underscore real, like it's the like munged version of it. I particularly, this is a big tip that I have is, if you are accepting like Boolean-ish parameters, or your config file has Boolean-ish values that are in there, try to allow the user to specify it in whatever type of Boolean they want, versus having to know which one should be in the config file. And this kind of does that. This also takes care of things where it's like in Ruby, anything at all besides nil and false is Boolean true. So even string false, which since Puppet everything is strings, sometimes you get string false into a template or something like that. That can cause problems when I've run into issues with that. If you just use string bool, it turns all kinds of stuff into actual Boolean values, and you can reference them later, and then use what the output should be in your template versus making the user know whether it's like uppercase no, lowercase no, maybe it's a 0, maybe it's false, maybe it's true in Klingon, who knows? They should only think like Boolean commands. The next thing is actually including the other parts of the module. So here you have, we've broken up the package, config, service into different classes, and those have their own areas of responsibility. So you include those. And then the next line is to set up a relationship. So that thing that Eric was showing earlier where it's like, make sure the SSH package is installed before the config file gets on there, and then that does a notify, I can't remember if it's notify or subscribe, but they're the same thing, it's just which side of it.
That's one is one.
Yeah. Then that sets that up so the config file will notify the service. So you'll see here that this is not a hyphen, this is actually a tilde, and that's the special syntax in Puppet for subscribe or notify kind of relationship. And then this is the scary part. It looks really scary, and it is kind of ugly, and this has been changed like going forward, and I'll describe or I'll explain kind of what's going on here, because this is something you're going to see a lot. Especially in modules that try to maintain any sort of backward compatibility. So this solves the problem of class containment. And so kind of, so you can understand what that even means, what is class containment? If you have, say, like, you have some file system mounts that need to happen, and a web application that needs to install, and a database server, and an Apache that needs to run. So you include all those things, and then you set up these relationships. So if, without class containment, say that my SQL module has the package config service thing, the service might try to start before the mount is there, because you're only making the relationship with the top level class. Since the inner classes that you included are not contained by the MySQL class, they don't have any dependencies. They don't inherit dependencies. So what you do to fix that is you wrap them or you contain them. So that's what this does. The anchor thing is a resource definition, or declaration rather. And what it's basically saying is like, here's a resource, and then here are all the dependencies of this fake resource. And so like, those need to happen before who install, who config, and all this. And then it ends, it sort of kind of bookends and sandwiches those classes in here, because if you declare a resource inside a class, that is contained. So it's kind of forcing it in there. And this solves that issue of when you're making a dependency against the whole module or the whole, like the top level class, it'll make those dependencies also go into, like you can treat this as one single unit. So your MySQL server has to be completely, fully configured and up and running according to the module before your web server will start or before your application will get deployed. So some of you are maybe more familiar with contain. There's a contain function now. Contain is the right way to do it going forward. The problem is that it came out in 3.4. So if you want backward compatibility with anything before Puppet 3.4, you have to use the anchor pattern because contain will just doesn't exist. But contain basically is a replacement for include. So instead of using include service, include config, you just contain and it automatically is contained and now you can reference it. So it really cleans up the syntax. But this is like, if you're publishing before, you should probably stick with this for now. Just as compatibility. That's pretty much the whole class. At least the top level class. It's just kind of arranging everything. It's not actually doing all that much work, but it's kind of arranging everything. One gotcha that I've run into before is variables, when you declare those, if you declare them after the includes, and the includes are inheriting the scope, those variables will not be in the scope. So that's, like Puppet is known for like, order doesn't matter or whatever, but this is actually one case where it does matter, because those variables get evaluated and then it dives into the foo install. So if that variable isn't already in scope, it won't be inside of foo install or foo config. So you want to set up all your variables before you include the subclasses. So we're going to talk about install. This is basically the thing, install the package. This can be as simple as this, and in a lot of cases it is, because your operating system already has a package that you're happy with and you like. Just ensure it, or just install the package. The ensure I like to put there for allowing people to very easily lock to a specific version. It's a class parameter on the top level class. You could ensure absent here, and that would probably break all sorts of other stuff later, but really if you're doing that, like, you're shooting yourself in the foot, stop doing that. This can be more complex if you want to. It's just kind of like the container that you put all of the stuff that's related to just installing the package in there, or installing the software. So this could be like a git clone with a compile step, or a tarball with untar, or like a file resource with a recursive, then you grab the entire package off of your Puppet master or something like that. Please don't do anything like that. If you need to deploy code that way, you should either probably be using something like Capistrano or Fabric to actually deploy the application code, or build a package for it and install it this way. Because if you have, say, a tarball or a git clone with a compile step, now Puppet is installing all these files that it doesn't know about, and it can't manage. So if you try to remove them or something like that, like if you really wanted to remove this package, you could ensure absent and the whole package would go away. So you trust your package manager to remove it for you. But I mean, it can be this simple, it can be more complex. The biggest thing is that this encapsulates that install package. And then the next thing is the config, and this is the same thing, just install or have a config file in there. We're using config path here, and that variable comes actually from the defaults class, and it goes all the way through into this by using the inherits, because it's inheriting that scope. And since that variable is set out here, out in the defaults, if you want to port this to a different operating system and it's got a different path for the config file, all you have to do is update the defaults class and then already know where to This makes it really nice. You don't have to modify this. You don't have to have a bunch of if statements in here. It puts all the logic in the defaults. And then here we're also using a template to generate the actual config file content that goes down there. So any variable that's in scope here, actually I'll talk about that in a minute. Also you'll notice that I don't have any kind of meta parameters on here like subscribe or anything like that, because that's being inherited by the class. So the foo config has the requirement that the package has to be installed. So this won't even try to run until the package is installed. And then we have the service, which for the most part is simple. It's just make sure the service is running and it's true. But again, you can have as complex as you want to. If you have something like if you're running the service under Daemon Tools or Supervisor E or something like that, or maybe you're running an operating system that has multiple different providers that it can use, and the default isn't the default isn't the one you want to use. You can just change the provider in here, and that's probably something you would put in the defaults class to, like, say which provider you should be using on, Fedora or something like that. Because maybe you don't like systemd and you want to know. And then we have the config file, which all the variables that are in scope at the time template is called come in as instance variables. This particular one is eRuby, which is like a kind of like, it's like a templating language for Ruby. It's really simple. You just have like some opening braces to break into Ruby code. You might see some code out there if you're looking at old modules where there are no @ signs in front there. That's because I think in Puppet 3 is when instance variables were the way to do it inside of templates. And that's just old stuff that hasn't been converted, but is deprecated and should be using instance variables. You probably get all kinds of warnings if you do. And then here you also see the Boolean normalization in action. So in this case, yes or no lowercase is the correct thing, but the user can just put true or false somewhere, or they can put on/off if they're using Hira, and Hira or YAML will actually convert that into Boolean, or string to bool I think will also do it. But they don't have to think about it, they just use whatever they're comfortable with, which is really, I think, very important. Previous notes, not sorry. So yeah, that's like the most basic of basic Puppet module. There's a lot of stuff in here, or there's a lot of stuff missing here if you want to publish the Forge. There's a lot more stuff that I want to talk about too. But that right there will give you proof. In a pretty nice and easy way to use. And so you can use foo with the traditional class declaration syntax, where you go like class foo, here are the parameters you want to supply. I'm a big fan of Hira class parameters, because that way I can just include foo wherever I need it, and if I need to override a setting somewhere, I just do it in Hira, which makes a lot more sense in my brain. Either way it works. One of the advantages of using Hira, of course, is that if you have multiple classes that both need foo, if they're using this syntax and they're both using the syntax, you'll get a duplicate resource definition error, and it's a nightmare. So that's why I just use this and then make sure that the class parameters are based on where in the chain and the hierarchy that machine falls are correct for that service. So a lot of packages have this concept of CompE directory, where you can have multiple config files that then get included into the main one, either in a conceptually concatenated form or some other method. For that, with Puppet, you would use a defined type to wrap the things that are inside a CompE directory. So every file that's in there, you use a type. And then you can, or like a good example is Apache vhost. Those are kind of like a CompE directory, at least on Debian, which is what I'm most familiar with. They have the sites available and sites enabled. Those are basically CompE directories for Apache. Or if you have CollectD has a CompE directory as well, and it'll take any plugins that you throw in there. That makes it nice so that multiple classes can say, I need this piece of functionality, and then you can have them on separate machines, or you can put them on separate machines and they'll combine as necessary. It uses a lot the role profile pattern. I don't know, or who's familiar with the role profile pattern? Right, go read up on it, it's awesome. But basically profiles are kind of like encapsulated bits of functionality for your entire infrastructure, including like monitoring or whatever else needs to happen on there, and using modules underneath as the low-level blocks. So you can have like, 3 things need this package, but one of them needs a configuration or like a special configuration, or like a web server. Maybe you have multiple websites on a web server. You can combine those into different classes, or you can put those on different classes and then combine them in a wrapper around that, and have no conflicts because they're just using a defined type. So to do this, to add support for that into this module, we need to modify a couple things. So we need to modify a couple files, and we have a couple of new files we need to add. So the first one we're going to modify is the defaults, and it might be hard to see, but the bold is kind of the changes. So we added the CompE path because on Debian and Red Hat they're in different directories, and also a place where the plugins actually live. And so in this case, we're adding support for plugins to the module for our package. So the plugins are just like files on disk that maybe have some code in them or something like that. And we are, this is where those plugins should live on those different operating systems. Then we go into the config resource, or the config class, and we actually manage the directory that those are in. The main reason for this is because I like to use purge and recurse, and what that does is any file that's in that directory that's not being managed by public will wipe it out. So if you have one of these CompE like config templates inside there, and then you take it away in your public code, it'll actually disappear on your server as well, which is really handy for things like monitoring, where there's a lot of files coming in and going out, or maybe if you are using like configuring Apache or something, and you move a site to another machine, it'll disappear off the original server. And then a template for it. So, or no, I'm sorry, not a template for that, but the modification to the main config file to actually include those. And since there's that variable set in the defaults file, or in the defaults class, we have right here, we can reference that and say, include this path that's defined outside of the class, or outside of the template, then start.conf, and it just loads it up for you. Assuming, obviously, that the system that you're managing with Puppet supports this, so we're going to assume that. And then there's the define type for the actual plugin itself, and this is a little bit different than a parameterized class because you can have multiple of them. The only thing that needs to happen, of course, is that they're unique names. But for defines, I'm fine with having non-default or fine with having parameters that don't have defaults, because a lot of times you're like, use this and just like in this case, we want to have a type on the plugin because there's no real good default other than like what's the type of the plugin you're installing. And then we're building the path parameter, so it has the same default there, but that's where the plugin should live, and you can override it if you want to put the plugin somewhere else. And then there's this verbose equals undef thing. So in the main class for the for this module, verbose has a default value of false. Here it's just undefined, which is basically saying it's not a required parameter, but it's not really true or false either. And I'll get into that in a minute. Those are, I call those tri-state booleans, but we'll get into that. So then we have validations, and we have our string bool again, and then of course the file resource for the plugin. Also, you'll note in here that there's a notify. It's way down at the bottom. Sorry. There's a notify that tells or refreshes the foo service class. So it's not doing it against the service itself, even though we know because we wrote it. The implementation of that class is just a wrapper around service. This makes it so if the service class needs to get more complex, this doesn't break because you're sending that notification to the service class as a whole, and it can handle it how it wants to inside. And you have to do it here because since this isn't like a class that is inheriting any relationships, you have to define those yourself. You could also put the require or the notify on when you declare the foo plugin when you're using it. But then every time someone uses it, they have to do that or it won't restart the service. It's easier just to do it inside here, and then they don't have to think about that too much. And then we have the config file for it. So we're using the name. The name is actually the very first thing it's like the title variable Like when you declare something, it's like foo plugin, and then you've got in quotes before the colon, the name there, that shows up in here. We have our parameters, and then we have this tri-state Boolean thing that I was talking about. So a lot of times you have a global setting on your system, or on your particular software package, that is a Boolean value, like verbosity, right? Sometimes you want to override that in a lower plugin or something. A good example of this is use DNS in Apache. So you don't want to have use DNS on for your entire thing, or your entire Apache server, but some host needs it somewhere, or maybe you want to have it, so you want to have it inside there. That's kind of where tri-state Boolean comes in. And the reason it's tri-state instead of just having a default of false is that if you don't specify that parameter at all versus like setting it to true or false, it'll come through in here as nil, and then this verbose doesn't even show up in your output. So it just inherits through the software the actual the value. If you explicitly set it, it'll show up in here as whatever is explicitly set. So it's like true, false, and not set. So it's kind of the third state. And I use this a lot in places where it's like I'm writing, there's like a plugin that I want to have an override for the whole system. They're really handy. It took me a little bit of thought to try to figure out like how to do it, because I was doing checks on like if defined, like in the manifest, if defined this, or the variable then set this value, but really it's just, you just convert it, since you have to have a second variable anyways for a string to bool to output into. You can just use it and check the original one, because if it's set, that won't be nil, it'll either be true or false. So it's kind of handy, it's a trick that I use quite a bit. And then here's kind of an example. So we include foo, which basically sets up the foo, the whole thing. And then we have two different plugins that we've declared. So there's web app, and it's got type passenger or whatever, and then the database, type MySQL, both true, and we have a custom path for it. And those all just go down into the template, and then you'll have the two config files sitting on disk after you're all done. And then you can even split this up into like the role profile pattern I was talking about, where two things are saying include foo, and they both have a plugin defined. Maybe one is like your actual application class that encapsulates this is everything that needs to run for this, just for like the Apache part or the web server part of our application, and then just the database part of the application. And down at the bottom, we put those both on the same machine, but they could be on different machines if we wanted to, and still work, or you can combine them with other things. The role profile pattern is something that deserves kind of a talk in itself, but this is kind of a hint, or not a hint, but just kind of like an intro to it, and how this fits in. So what if you don't have, what if your software doesn't support CompE? Right? Like AJ Proxy is a good example. It has one config file, and that's it. There's no like include whatever. There might be in 1.5, I don't know, I haven't checked. But there's no like way to include other files. So you have to spit out the whole file, but you want to maintain this functionality. So there's a module from Puppet Labs called Puppet Labs Concat. And basically what it does is it takes a file, and you can declare parts of that file as resources of their own. And then it will compile all together and spit out one single file. So in this case, we would just change the base config class to use a concat resource, which is very similar in syntax to a file. And then you use concat fragments to specify different parts of it. And you can set like the order, so if you need this particular piece should be all the way at the top, or maybe it doesn't really matter where it goes. That's kind of where you can use concat to build this file, and then in the actual plugin, you just use concat again. So the bold is where we changed it. So instead of a file resource, now it's a concat. That should actually be concat fragment. I'm sorry, the concat fragment, and then we have the target as the config file. So that makes it so you can kind of emulate a CompE model in Puppet if your application doesn't support it, which is also very handy, especially for things like AJ Proxy. So that's a lot of the code. that I talked about. But of course, the other thing, the other big thing your users see is the documentation. There isn't any documentation in any of that, and for the most part, I don't put docs inside the module because I just have a really strong README I try to. Just a brief statement about what the module is managing, so that maybe if someone stumbles upon it, they're like, now they can kind of use it as a way to discover software instead of just discovering your module. You should document all the top level class parameters, and what they do, and even maybe going as far as to link to the documentation of the package you're writing a module for, and saying like, here's the docs that explain what this parameter is. That's really helpful for someone looking at the code or looking at your module and evaluating your module to see if it does what they need it to do, and also what other capabilities it has. That's why I also I try to make it so every setting in the config file is a class parameter, if it makes sense to. Just because then it supports everything out of the box, and I don't have to change it later when someone's like, oh, hey, you got support for this, and then next week you got support for that. If you have any defined types, you should document those and what their parameters are as well, and what their kind of purpose is. If you have optional dependencies, say you have a plugin that needs Java, but it's the only one that needs Java. You don't want to make your whole class, and you don't want to make your whole class depend on like a Puddle Labs Java or something like that. You could say like, well, if you want this, you also need to include this in your system, and this can work. So that way, if someone's going to use that, they'll see that they need to also bring in the Java module, or like a good example of this is where you can get in trouble if you automatically include the dependency. Is there are 4 Python modules on Forge. I think one of them is now like a Public Labs, not supported, but approved module. But for the longest time, there are 4 on Forge, and like some people are using one, some people are using another, and if it's an optional dependency, especially, maybe you don't need the Python component of that, and it's now going to conflict with someone else's module, and chances are the one that was there first is going to win in terms of like, do I use this module, or do I either write my own or find a different one? So like making hard dependencies versus optional dependencies. And then really the biggest thing is like common examples of how to use it. The Public Labs MCP module is a great example of a module that does this very well. They have like 10 different scenarios of like, I just want to have an NTP server that talks to pool.ntp.org. Boom, it shows you the class parameter, how to use it, done. It shows you all these other advanced, or not maybe advanced, but just different configurations that are kind of like case studies. So if you think about them as case studies, like how would you implement this? Those are great because it helps people use or know like how to use it. Because you can have the best documentation on what it does in the world, but if nobody can figure out how to use it, then you can't. Like nobody's going to use it. If you guys or if you folks know about QMail is something I really enjoyed a long time ago, but the documentation is terrible because it's perfect. Like it tells you exactly what everything does and whatnot, but it doesn't say how to use it. So there's all these like moving parts that you don't even know. What's QMail remote? How does QMail LSpawn work into this? If you have good examples, it makes it really easy to use your class or your module. So I think I'm running a little short on time.
You've got plenty of time.
Oh, really? Okay.
The food's not here yet. You can run till 12.
Okay. So I would be remiss in doing these if I didn't talk about testing. I have to admit I'm really bad at writing tests for modules. That's one of the reasons I haven't published on the Forge yet, is because most of my modules that I've written don't have tests, but I'm working to try to change that. So hopefully I can help. A lot of it was kind of a barrier to entry thing, like what do I need to test? Because I don't come from a software development background, so I don't already have like test-driven development ingrained in my brain. And so like knowing what to test, am I over-testing, am I under-testing, am I completely missing something? If you cover some of the basics that I'm going to bring up here, you'll weed out a lot of problems. mostly typos, but those are big sources of problems and stuff that you're going to have to support later. So this is by no means a complete test suite or like how to actually set it up, just because there's not enough time to cover that. But this is more of a kind of like what you should test, not necessarily how you should test it. So fundamental level, you want to make sure that the test or that the class compiles and that it works and that there's no errors. You can do this a number of ways with like a syntax checker or something like that, but really just try to compile it. Does it break? Okay, then fix that. And then make sure that it has all the other classes that you have. So this is basically saying like on the food class with default parameters, it compiles and it has all these other classes within it. And then you go a little bit further and check that any resources that should be output by the module as a whole are also there. So you got your package, you got your config file, you got your foo.d directory, and you got your service. So those things should be there. This helps weed out things like I mistyped the config file somewhere, or I have the wrong parameter or something like that. And once this is done, like this is all one-time stuff. Once this is done, like you just, every time you're modifying your code, you rerun your tests, and this stuff passes. So it feels very like, why should I do this? Because this is duplicating what is already in the manifest. But this just makes sure that your manifest doesn't break. Like this is kind of your intent. In a test-driven development world, you would actually write all this first. But it's hard for me to really think about that in terms of Puppet, so I usually write the implementation and then never write tests. But sometimes I go back and write tests. And then you go even further and make sure that with the default values on the class parameter that the contents of the config file are what you want. And that the settings are present and that sort of thing. So this is, in a way, you're testing the class parameters, which isn't necessarily a good thing, but you do want to make sure that given the same values that it doesn't like miss something entirely in your config. Like maybe you have an if statement somewhere that should output something even with just the defaults, and it's not, this will catch that. So it's a little bit of repeating yourself because you're repeating the values of the default class parameters in what the output is, but it also helps so much find typos. Like seriously, testing the content of your config file weeds out typos all the time, either in the manifest or in the test itself or in the config file, the template. And then I go through and I'll set all the parameters. And then in the case of a Boolean or even a tri-state Boolean, I test that both of those work. So the true output's the exact thing. Like in this case, it's supposed to be yes or no and false. I make sure to test those. And that's again just checking your logic and making sure that because sometimes if you mistype a parameter name or something like that in your test, especially like where it says port, if I spelled prot instead of port, the test would fail because the default value would be there and not the fake one, or not the other one, the actual specified parameter. So that weeds out, I mean, I'm trying to think of an example of when it weeded out, or a case where it weeded out a typo in the actual template that didn't get caught by the first test that was checking that it got there to begin with, but this just helps. It's just testing, positive and negative, like works and doesn't work kind of things, or when it should fail, or when it should be something other than the default. So another thing that you do is, Beaker is a new thing in the Puppet world, where it'll actually install or run your module against a running system and check that it works. I haven't used Beaker myself. It's something that is a serious deficiency that I need to fix, but I'm bringing it up here because it's something you should all also look into, because it can help handle scenarios where things break because the config file itself is just wrong, or maybe you need to test against different versions of the software. Like Redis is a good example of between 2.4 and 2.8, somewhere in there, they changed the name of one of the parameters. It's more correct now, but my Redis module broke because it was putting in the wrong value in the 2.8 config file, or the wrong parameter name in the 2.8 config file, and it just caused Redis to fail. if I had been running Beaker, I wouldn't even install the server until the Beaker test ran. And I would have found that well before. So I'm not covering like how to use Beaker, but just like that you should look into it. Also, there's just not enough time. The testing public modules and testing public code is something that you can have an entire conference on, not just like a talk or like part of the talk. So if you're publishing to Forge, some tips to do is limit your dependencies. So I mentioned earlier the 4 Python modules. If you try to stick to using the primitives that are built into Puppet, and as well as like a couple that I like approved modules on my list for dependencies are things like Puppet Labs standard lib, which pretty much everybody has and is very handy, or Puppet Labs concat. Or even things like Puppet Labs Java, because it's really nicely done. Try to limit your dependencies to things that have a high number of downloads, like whatever gated quality you want, just so that if other people are using it, there's a less chance of having a dependency conflict, where now they either have to maintain a fork and either completely rewrite your module or rewrite big chunks of it or something like that, or just not use it, find either something else or write their own, which then breeds more dependencies because there's now 4 things that rely on each of the Python modules. Trying to stick with like more common dependencies if you're doing that. If you have, say your package, you need a user install in the system. This is something that I've run into a couple times where the module itself is like, okay, well, I don't know if it's the MongoDB module, but an example, the MongoDB module might say like, well, the MongoDB user needs to exist on the system, which for the most part, it's probably going to get installed by your package manager, and if not, Puppet's going to create it for you. But I manage all of my system users with Puppet anyways. So now we've got to look at resources, and I either have to somehow not manage the MongoDB user, like one-off that, and hope that the module is going to do it properly, or fork their module and delete that code. So if you have anything like that, put a parameter or something on there that says like don't manage user. Just so that people like me who are managing the users and or package repos or any number of things don't run into issues with using your module. Also things like using the pip provider or the gem provider, both of them need to have pip or gem installed, and so sometimes you'll have like install pip, install gem. And then anchor pattern, of course, if you're using the module or if you're publishing the Forge versus contain. And I try to use include instead of class declaration, just because then there's less chance that I'm going to collide with somebody else's. So here's some resources. 2 really good modules to use as examples are the NTP, Puppet Labs NTP module, which is pretty much the first Puppet module I encountered on the Forge. It's really well written, it follows this pattern almost correctly. The collecting module has a lot of defined types and a lot of like plugin stuff that like some of the plugins have defined types for them. And it's also one that I contribute a lot to because I use collecting like crazy. And then you have standard lib, concat, and then a couple links for like where to find information about testing. And that's it. Do you have any questions, anybody? Yes.
What do you use to write your modules?
What do I use to write my modules? I primarily just use Vim, just because I've never been an IDE person. There are things like Geppetto is a good thing. I think it's the Puppet Labs official now, like they acquired Geppetto or something. That'll help you do more IDE type stuff with it. I just haven't used it because I've been using Vim since before Geppetto was a thing.
How many lines is the biggest module?
How many lines is the biggest module I've ever written? Right now it's the graphite module that I'm working on, and it's not the module itself that's so many lines, it's that I have like 500 tests. Because there's so many parameters in graphite, that I test each individual one. Their on-off values, their like everything. Right? It tests lots of them. And that's the one that I'm probably going to be publishing to Forge like soon. I wanted to try to get it done before today, but so I could be like, and also you can go check out my CompE or my graphite one. Yeah. Probably though 200? I don't know. I don't for sure. Yes. Cool. Well, thanks a lot. And obligatory rehiring. And there's all